Hey everybody, hope you're doing well. This video concludes week 7 of the 4th marking period and is the second to last new lesson that you're going to have for the entire school year. This video is going to walk you through how to multiply rational expressions, so it's going to build heavily off of the previous lesson where you learned how to simplify. Now we are simply taking a look at putting a couple of them together using multiplication. So, as a brief review, I want you to look at the box at the top right of the screen. If you recall how multiplying fractions works, so if I gave you two fractions like 2/3 times 4/5, you could see in the box what happens is you multiply across, okay? So you put your numerators, multiply them together, put your denominators, multiply them together, and then you would simplify as far as you can. With these fractions that have polynomial expressions, we're not going to necessarily multiply all the terms together as big polynomials. So we're not going to have these crazy answers that have, x squareds and x cubes and all these different terms, because that's going to make it very hard for us to cancel things out. If you recall from the last video, that was the whole point of simplifying these things, was to factor things apart and make them as simple as possible. We're going to continue the same thing in this video. The only difference is when we multiply, we're going to factor more things apart, cancel more things, and simplify the same way we would. It's just a matter of working our way across the entire fraction. So you can see the two quick steps on how to multiply rational expressions. We're still going to factor each numerator and denominator. What we're then going to do is treat it as one big fraction. So that way we can look across the whole top, then across the whole bottom, and see what does cancel out. So let's go ahead and talk through. There are going to be, I believe, 5 examples here. There is a second slide to this video, so there will be a few examples here we'll walk through and multiply these together. So, first example here, you've got two fractions being multiplied. What we're going to do, again, just like we did in the last video, we're going to focus on one fraction at a time, one piece of the fraction at a time. So, first thing I'm going to do, focus on the numerator and the first fraction, so top left, 10a minus 20. First thing I want to figure out is, well, how does that factor apart? First thing we check for is always is a GCF. I can take a GCF out of 10a minus 20. I can take a 10 out and be left with a minus 2. Okay, so top left is done. Now we're going to focus on the bottom left. So the denominator of the first fraction. A squared plus 11a plus 28. No GCF, but it's a trinomial. Multiply to c, add to b. So what multiplies to 28 and adds to 11? Well, the two numbers that will do that, positive 4, positive 7. Now we're going to take a look at the second fraction. So let's look at the numerator of the second fraction. So top right, if you will, a plus 4. Well, there's no GCF. There's no difference of squares, even though there's two terms. Nothing, they don't both square root. They're not being subtracted. So we can't do anything with that. We're just going to leave that as a plus 4. And last but not least, we focus bottom right of the 3a minus 6. Again, we can take a GCF out, take out a 3, and be left with a minus 2. So we factor all the pieces. It's a lot of factoring that you'll have to do in these problems. Some of it will be quick, some of it will take a little bit longer. It just depends on, again, your expressions and your ability to do this quickly in your head. But now we're going to look at this here. So like I said up at the top, multiplying occurs going across. Here's what that means though. We're not distributing this whole thing together. That would be pointless. What we're going to do instead is, once you've got it broken down, we're going to treat this as one gigantic fraction. Since it's being multiplied, it can combine as one fraction. All I have to do now is look at the top and the bottom and see, well, what can I cancel? There's an a minus 2 in the top and the bottom. It doesn't matter that they're from different fractions. Since they're being multiplied, it all becomes one fraction anyway. The a minus 2's cancel. So, do the a plus 4's. What that leaves me with is a 10 up in the top, a 3, and an a plus 7 in the bottom. There's no more reducing. That's my final answer. That's how you multiply rational expressions. So it's the same factoring we've been doing for weeks, All we're doing now is we're doing two fractions at the same time. It's just a lot more things to factor, a lot more things to break apart. Combining this one big fraction by connecting the fraction bars, and we cancel from there. That's what we're going to look at here in the rest of these problems. So we take a look here at number 2. Same deal. We're going to focus one piece at a time. So let's start top left with the 5x plus 5. I can take a 5 out and be left with x plus 1. Bottom left, x plus 3. No GCF. Nothing I can do with that. That's going to stay x plus 3. Now we're going to focus top right. It's a trinomial, no GCF there, so we're going to use our trinomial strategy. What multiplies to 6 adds to 5, 2, and 3. Bottom right is an x plus 1. Nothing I can do with that, so I'm just going to write it down. So in this case, there was only a couple of things you had to factor. Not too bad. Again, once I factor everything, that's what I'm going to... Again, you don't have to necessarily draw this like I am. I just want you to see that now it just becomes one big fraction. So I look. X plus 1's cancel. X plus 3's cancel. So up top, I have 5 times x plus 2. The bottom, everything cancels. When everything cancels, you put a 1 in. Since the 1's on the bottom, technically I don't need it. So my final answer is 5 times x plus 2. Now you'll notice in both of these problems, could I have distributed the 3 into the first one and the 5 into the second one? Sure, but again, it's an extra step that I don't need you to take. You can leave these answers as they are broken apart. All right, let's keep it going here. Number 3. So we got top left here is another trinomial. Now, some of you have been struggling with ones that look like this. Remember, if the middle term doesn't look like it has a number, it does. There's a 1 there, okay? So in the top left, I'm trying to figure out what multiplies negative 12 adds to positive 1. Two numbers that will do that are positive 4. Use the right variable here. And negative 3. Now, so you'll notice there are a couple of times I had a bad habit of putting x's in. If you do that, that's not a big deal to me. But just for the sake of trying to be consistent here, I'm going to try to use the right letters. But if you make everything x's, again, not the end of the world. All right, bottom left, 5b plus 10. There's a GCF of 5. Take that out. b plus 2. Top right. So it doesn't look like there's much there. Negative b minus 2. Anytime you have a leading coefficient that's negative, though, you should take it out. So if I take the negative out, well, negative what in this case? So we don't see any common numbers. I don't see any common letters. That means you can take out a negative 1. You'll see why this is important, why this matters in this case. If I take out a negative 1, that's going to flip the sign of both of these terms. If you look carefully, all of a sudden now you have a factor that's going to cancel. So that'll be helpful here as we continue with our problem. And then bottom right here, we've got ourselves a trinomial, no GCF, so we're just going to go ahead. What multiplies to 4 and adds to 5? Positive 4 and positive 1. So I've now factored everything, and now I'm going to make this one big fraction. So what cancels? The b plus 2's, the b plus 4's. So up at the top, I have negative 1 times b minus 3 over 5 times b plus 1. You can leave your answer like that. Technically, since it's a negative 1, you could just write it as a negative and then the b minus 3 in parentheses. I don't really care. Either way is fine. You can leave it exactly as I've written it here, though. All right, number 4. Now, you'll notice number 4, these are technically two fractions. It's just that one of them doesn't look like a fraction. So let's think. We've done this mostly with graphing things when we've had to come up with slopes. We've made things fractions on purpose. So the first one we see is a fraction. The second one's not. If I want to make something a fraction, we know to put it over 1. I think that'll be helpful for you to do so you visually can see you still have two fractions, and it's easier to line everything up. So let's go ahead and break apart what we can. Top left is negative 3m. We're just going to leave it as negative 3m. Reason why I'm not taking a negative out of that is because it's only one singular term, so it's not going to really get us anywhere. Bottom left, we're going to go ahead and break that trinomial apart. No GCF, so what multiplies to 10? That's negative 7, negative 5, negative 2. Top right, m minus 5, that doesn't go anywhere. Bottom right's a 1, so that's just 1. So here's a problem here. We only had really one thing to factor. So we see, again, if you need a visual, connect the bar. It's one big fraction. The m minus 5's cancel. Negative 3m is what's left on the top. 1 times m minus 2 on the bottom. If you leave it like this, it's fine. Since the bottom's being multiplied by 1, you could write it without the 1 as well. Up to you either way. Both answers are fine. All right, last problem here. It's the same question. It's just written as a multiple choice. Again, this would have been more if you were taking the keystones. This would have been a little bit more relevant because this is probably how you'd see the question. But one more here to practice. It's saying, what is the product? So product is a word that means let's multiply these guys together. So I'm going to go ahead and write this as a product. And then I'm going to go ahead and do the same thing I was doing in the last 4 problems. So top left, x squared minus 1, that can be broken apart using difference of squares. X plus 1, x minus 1. Take the square root of each term, 1 gets a plus, 1 gets a minus. Bottom left I can't do anything with. Top right I can't do anything with. Bottom right I can take a GCF of a 3 out, leaving me with an x minus 1. Connect it as one big fraction bar. X plus 1's go away. X minus 1's go away. Leaving me with an x plus 3 on top and a 3 on the bottom. Again, don't make a goofy mistake where you try to cancel the 3's out. Again, the 3 up at the top is connected with x, with that x plus in front of it. You cannot cancel out part of an addition or subtraction expression unless you cancel out the whole thing. So the 3's do not cancel. You're left with x plus 3 over 3, which would match up with answer option D. So that's how you go through and multiply expressions. Again, hopefully you see it's just building off of what we did in the last lesson. It's all the same factoring you've been doing for the last several weeks. It's just a matter of there's a little bit more of it. You just have to focus on doing one little piece at a time and ultimately get things to cancel from there. So that's how we do multiplication here with these rational expressions. Graded assignment that goes with it, just a handful of problems once again. Make sure you complete it, submit it here in a timely manner. We only have a couple weeks left, so make sure you're getting your work caught up and getting everything submitted like you're supposed to. So if you have any questions, need any extra help, again, send me a message on Schoology, shoot me an email, or stop by my office hours on Zoom. I'll be more than happy to help you out. Otherwise, thanks for watching. Stay safe, stay healthy, and we'll see you next time.